The multiples of a number are the values you get when you add the number to itself multiple times. For example, the first few multiples of 6 are 6, 12, 18, 24, 30, and 36. This list can continue as long as you want. Example, list the first 10 multiples of 2, 5, and 7. The first 10 multiples of 2 are 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. The first 10 multiples of 5 are 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. And the first 10 multiples of 7 are 7, 14, 21, 28, 35, 42, 49, 56, 63, and 70. This type of exercise leads us to a natural question. Can we tell whether one number is a multiple of another number? For example, is 48 a multiple of 6? If you happen to recognize that 6 times 8 is equal to 48, then you could reason that 48 is a multiple of 6, because when you add 6 to itself 8 times, you will get 48. But where did the number 8 come from? For many students, the number appears seemingly by magic. They just see that 48 is equal to 6 times 8. For most of those students, this comes from having a lot of experience with numbers. They've seen the combination 6 times 8 equals 48 enough times that they just recognize that it's there. But that type of experience will not help us with numbers that are larger or less familiar, like 462. So how is it that you can start with the numbers 48 and 6 and end up with the number 8? That number is actually obtained by performing a division calculation. 48 divided by 6 equals 8. And this gives us the idea that we need to create a definition. Definition. The number a is a multiple of the number b if a divided by b has no remainder. Example. Is it true that 42 is a multiple of 7? Even if your brain immediately tells you that the answer is yes, it is important to take the time to think through the definition to make sure you understand the connection. In this problem, the number a is 42 and the number b is 7. So we can compute 42 divided by 7 to get 6. Since this has no remainder, the statement 42 is a multiple of 7 is true. Example. Is it true that 5 is a multiple of 35? This is where students get themselves into trouble if they move too quickly and don't think about what they're doing. Their brains will immediately spit out the number 7, and they will decide that there's no remainder. Unfortunately, that's wrong. Let's look at the definition more closely and identify the different values in it. The number a is a multiple of the number b if a divided by b has no remainder. In this case, the number a is 5, and the number b is 35. This means we have to do the calculation 5 divided by 35. 5 divided by 35 says we have 5 objects, and we're trying to make groups of 35. We don't have enough pieces to even make one group, so we have 5 out of 35 pieces that we need to make a grouping. In other words, this calculation has a remainder. Since 5 divided by 35 has a remainder, the statement 5 is a multiple of 35 is false. Pay close attention to these two examples because they highlight the importance of thinking clearly. We will now introduce 2 more vocabulary words. A common multiple is a number that is a shared multiple of different numbers. The least common multiple is the smallest of all the common multiples. We often denote this by LCM. Just as with the greatest common divisor, the least common multiple will also be used often when working with fractions. Example, find the least common multiple of 6 and 10. We will find the least common multiple by writing out the multiples of each number and looking for the smallest number that shows up in both lists. The first several multiples of 6 are 6, 12, 18, 24, 30, 36, 42, 48, 54, and 60. The first several multiples of 10 are 10, 20, 30, 40, 50, 60, 70, and 80. If we look at these two lists, we can see that the numbers 30 and 60 both appear on them. This means that 30 and 60 are both common multiples. But this problem is asking us to find the least common multiple. This means that we want to pick the smallest of these two, which is 30. In this problem, we ended up writing out more numbers than we needed to. When we were writing out the multiples of 6, if we noticed that 30 was a multiple of 10, we could have just stopped there. But if you did not notice that, you would not be making a mistake by writing out extra multiples. Example, find the least common multiple of 9 and 11. This is an example of where your ability to perform arithmetic quickly and correctly is to your advantage. The first several multiples of 9 are 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, and 99. The first several multiples of 11 are 11, 22, 33, 44, 55, 66, 77, 88, and 99. From these two lists, we can see that 99 is the least common multiple. For this section, we want you to write out the multiples of the individual numbers as we've done here, so that you'll get practice and gain experience working with these numbers.